In this video, we'll take a look at a couple of questions from section 1.7 homework, inverse functions. The first question is question number 5. It says, let f of x equal the square root of 5 minus x plus 4. And what we want to do is find the domain and the range of that function first. So the domain of the function is the values that we can allow x to be. And x can be anything as long as it doesn't make the inside of the square root negative. So to figure out what x can be, or can't be, we take 5 minus x, set it greater than or equal to 0, and those are the values we can use for x. Add x to both sides. We get 5 is greater than or equal to x, or x is less than or equal to 5, if you want to write it that way. So that's everything in interval notation, from negative infinity to 5. The range is what are the values, the y values. So since x is restricted, the domain is restricted, then the range will be restricted as well. The restriction starts with 5, so I'm going to go ahead and see what happens in the function when I put in 5. I end up with 5 minus 5 plus 4. So I know the 0.54 is on the graph. And then if I put in smaller values of 5, like for example 4, what happens? I get the square root of 5 minus 4 plus 4. Square root of 1 plus 4 is 5, so the y's are increasing. So I think that the range, the smallest value of the range can be 4, because that's the greatest value of x. And then as x values decrease, the y values increase. Another way to think about it is go ahead and graph the function. So let me get a graphing calculator. Go to y equals, and type in the square root of 5 minus x plus 4. Graph the function. And I've also got the line y equals x in there because we have to find the inverse. So our point for the range is 4, and then it increases. So the range is from 4 to positive infinity. All right, next part of the question asks us to find the inverse. I know this function has an inverse because it's 1-to-1 by looking at the graph. So to find the inverse, rewrite your function with the notation y instead of f of x. Then take your x and y coordinates and switch places. And solve for y. So I'm going to subtract 4 from each side. We end up with x minus 4 equals the square root of 5 minus y. Square both sides. X minus 4 squared is equal to the square root squared is 5 minus y. Subtract 5 from each side. X minus 4 squared minus 5 is equal to a negative, just a negative y. Now I want to multiply through by a negative to get y positive. So I get y is equal to 5 minus parentheses x minus 4 squared. Okay. You could also write it as negative x minus 4 squared minus 5. Now I can replace that notation now that I have the inverse of 5 minus x minus 4 squared. So that's my inverse. Now notice the graph of that would be a parabola, but when we have the inverse and we look at the domain and range, we can't use the entire parabola because we're only looking at a portion of it. So let me get back to the graph. So when I type in the second function that we just found, the inverse, I get 5 minus parentheses x minus 4 parentheses closed, squared. I'm going to graph. So notice it's the entire parabola. I only want the portion of the parabola that's going to be a reflection along the line y equals x. So it's not the entire domain. And what we look at whenever you have your original function domain and range, here, the inverse function is going to take the domain and range and switch. So if the x values I can use in my original function are negative infinity to 5, that's going to be the range of my inverse function. If the range of my original function is 4 to infinity, then that's going to be the domain of my inverse. So x is switch and y switch, that means that domains and ranges switch as well. Okay. All right, next question is question number 8. Find the inverse of the function. This is a linear function, negative 5/4 x minus 4. Draw the function and its inverse. So let's draw the function first. We've got y is equal to, let's see, mx plus b. We know the slope is negative 5/4. That means we could use negative 5/4 or 5 over negative 4 when we're counting for the slope. The y-intercept is 0, negative 4. So I'm going to go ahead and graph that. So I know a coordinate of y-intercept is 0, negative 4. And then I'm going to count either up 5 to the left 4 or down 5 to the right 4. Well, my graph doesn't have a bunch of room on the bottom, so I'm going to use this version of slope and count up 5, 1, 2, 3, 4, 5 to the left 4. So there's the graph of the line that we're given. Now, it doesn't say that it wants you to find the inverse. It just wants you to draw the function in its inverse. There are reflections over the line y is equal to x, so I'm going to use the points that I have on the graph already. So my original function points, I know that I have 0, negative 4, and when I counted up 5 to the left 4 and landed here, I know that I have a coordinate negative 4, 1. So on the inverse, I just need 2 points to make a line. I'm going to take my coordinates and switch. Negative 4, 0, and 1, negative 4. Negative 4, 0, and 1, negative 4. And then connect those two. And that's going to be the inverse without actually having to find the inverse. If you do want to find the inverse, you would take y is equal to negative 5/4 x minus 4. You would switch the x and y coordinates and solve for y.